discuss about the laws of thermodynamics. Thermodynamics is a branch of physics that deals with heat, work and temperature and their relation to energy, radiation and properties of matter. The first thermodynamic textbook was written by Rankine in the year of 1859, and also he developed a Rankine scale which is equivalent to Kelvin scale. System and then surrounding in thermodynamics. A system is an object or it made by particles that is being studied. The rest of the system is known as the thermodynamic surroundings. Both system and then surrounding is separated by boundaries. A boundary may be fixed or movable. Before going to the laws of thermodynamics, we need to understand a Carnot cycle. A Carnot heat engine contains three bodies: hot body, working body, cold body, that is heat, work, temperature. The behavior of these quantities is governed by the laws of thermodynamics, that is that characterize thermodynamic system at thermodynamic equilibrium. Next, we discuss the laws one by one. Zeroth law of thermodynamics. It states that if two thermodynamic systems are each in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. For understanding the zeroth law of thermodynamics, let me consider three systems A, B and C. T1 is the temperature of system A, T2 is the temperature of system B and T3 is the temperature of system C. If T1 is equal to T3, similarly T2 is equal to T3, then automatically T1 is equal to T2. For fine understanding, we consider three objects as a system. Here A is a refrigerator, it present at 5 degrees centigrade. Then the objects B and C. Here B is a vegetable and C is a curd. Initially both vegetable and then curd present at room temperature of around 28 degrees centigrade. Now we insert both vegetable and curd into the refrigerator. Heat transfer takes place. After some time, both vegetable and curd attain the refrigerator temperature. Now the refrigerator and vegetable are present in thermal equilibrium. Similarly, the refrigerator and curd present in thermal equilibrium. And finally, both vegetable and curd present in same temperature, that is the temperature of refrigerator. That is the zeroth law of thermodynamics. First law of thermodynamics. It states that for a thermodynamic process without transfer of matter, the total energy of an isolated system is constant. Energy can be transformed from one form to another, but can be neither created nor destroyed. Mathematically, the first law of thermodynamics can be represented as delta U equal to Q minus W. Here, delta U denotes the change in internal energy of a closed system, Q denotes the quantity of energy supplied to the system, and W denotes the amount of thermodynamic work done by the system. In order to understand the first law of thermodynamics, let me consider a closed system. State 1, it has a definite volume. Now we have provided a certain amount of heat energy to the closed system. By using this heat energy, a system done some kind of work, so it's compressed, along with a certain amount of energy utilized by the system to increase their internal energy. Now mathematically we write Q equal to W plus delta U. Here Q denotes the amount of heat energy supplied to the system, W denotes the work done by the system, and delta U mean change in internal energy, that is E2 minus E1. By rearranging this equation, we get delta U equal to Q minus W. That is, the change in internal energy of a closed system is equal to the difference between the amount of heat energy supplied to the system and work done by the system. That is conservation of energy. This is known as the first law of thermodynamics. Second law law of thermodynamics, it states that the total entropy of an isolated system can never decrease over time and is constant if all the processes are reversible. In order to understand the second law of thermodynamics, let we consider two objects A and B. A present at a higher temperature, B present at a lower temperature. If we connect both the systems to each other, heat transfer takes place. Heat transferred from higher region to lower region, it is a spontaneous process. During this heat transfer, the entropy gets increased. After some time, both the systems present at thermal equilibrium. Once it attains the thermal equilibrium, the entropy never change. For more common, the heat can never pass from the colder region to hotter region. It is a non-spontaneous process. For fine understanding, let me consider one more example. If you take a glass full of water, water present at 95 degrees centigrade, that is the system. The environment is the surrounding. If we connect both the system and then surrounding, heat transfer takes place, which means heat transferred from water to environment. During this process, entropy gets increased. After some time, it attains the thermal equilibrium. Once it attains the thermal equilibrium, there is no change in entropy. Generally, entropy denoted by the symbol S. It is nothing but degree of randomness. Day by day, the total entropy of universe gets increases. This is the second law of thermodynamics. Third law of thermodynamics, it states that the entropy of a system approaches a constant value as its temperature approaches absolute zero. For fine understanding, let me consider a perfect crystalline solid at 0 degrees centigrade. In perfect crystalline solid, the atoms or molecules arranged in a regular manner, so the degree of randomness is quite low, which means at 0 degrees centigrade, the entropy will become 0. Suppose if we increasing the temperature from 0 degrees centigrade to higher degree centigrade, the molecules underwent some kind of motion, either vibration, rotation or translation. So if increasing the temperature, the degree of randomness gets increases, which means the temperature is greater than 0, the entropy is always greater than 0. In general, chemical compounds exist in three different forms: solids, liquids and gaseous forms. In solids, atoms are arranged in a regular manner, so the degree of randomness is quite low, entropy is low. In liquids, atoms underwent different kind of motions, so the degree of randomness is greater than the solids, so entropy is also greater than the solids. In gaseous form, the atoms underwent different kind of motions more frequently than liquid and solids, so the degree of randomness is more greater than the solid and liquids. So the entropy increases from solids to liquid and liquids to gases. And one more thing, at 0 degrees centigrade, the above mentioned motions like vibration, rotation and translation becomes highly restricted. So finally, if temperature T equal to 0, the entropy is almost equal to 0. If temperature is greater than 0, entropy is always greater than the 0. And this is the third law of thermodynamics.